Hi everyone, this is Naila Raswan, and today I'm going to speak to you about a topic majority of us would have never thought about. Imagine switching on your laptop or your desktop. Have you ever wondered how it is that the Windows, that is, if you're using the Windows operating system, how it is that the OS boots up? So today I will be taking you on that journey. We will explore what happens when a Windows OS boots up. Even though this process may seem like a normal thing nowadays, where we just switch on that, the power button, and in a few seconds, everything is on. But it is a complex sequence of events that transforms a dormant machine into a functional computer. So by the end of this seminar, you will gain a better understanding of the step-by-step boot processes, the role of key components like the BIOS, kernel, and drivers. Finally, how troubleshooting at each stage can help solve boot issues. Let's get started. First, we will go through the boot process overview. So when you press the power button, a chain reaction begins. This process is divided into several key stages. First one is power on self-test, or in short, POST. Second, loading the bootloader. Third, loading the kernel. And finally, the fourth, initializing system services and the user interface. So let's break each of these down. POST, or power on self-test. When power flows to your computer, the BIOS or UEFI firmware clicks into action. The BIOS is a tiny program stored on a chip on your motherboard. Its job? To ensure that all the essential hardware is functioning correctly before handing over control to the operating system. POST verifies components like the CPU, memory, and input. That means it does hardware checks. If a hardware issue is detected, POST may display a series of error codes or beep patterns. If POST completes successfully, the BIOS moves on to locate the boot device, which could be either your hard drive or SSD. This bootloader, it is a small program responsible for loading the operating system into memory. For Windows, this is the Windows Boot Manager. And here's what happens. BIOS hands control to the bootloader by locating the first sector of the active partition, called the Master Boot Record, or MBR, or GUID Partition Table, or GPT, for newer systems. Boot Manager reads the boot configuration data file to determine which operating system to load. So it is the bootloader that ensures all the necessary files are available for the operating system to start. Once the bootloader has done its job, it passes control to the Windows kernel. You can think of the kernel as the core brain of your operating system. It is responsible for managing hardware and software interactions. The hardware abstraction layer, or HAL, and kernel are loaded into memory. HAL acts as a bridge between hardware and Windows. Basic drivers for storage, input, and output devices are initialized. The kernel then reads the Windows registry, a database that stores configuration settings and installed applications. At this stage, Windows is transitioning from raw hardware interaction to a software-controlled environment. At this point, the session manager subsystem takes over. It starts critical processes like WinLogon, which manages user logins and loads user profiles, CSRSS, which handles graphical and text-based user interfaces, services.exe, which launches essential services like networking, security, and the task scheduler. This is where Windows becomes recognizable. And you will see the login screen signaling that the boot process is almost complete. When you enter your credentials, Windows finalizes the boot process. Your settings and preferences are retrieved from the registry. The graphical user interface or the GUI is launched, displaying the start menu, desktop icons, and taskbar. Applications configured to run on startup, like antivirus software, begin to load. And your computer is now fully operational and ready for you to use. So this is how your Windows OS loads, or this is how the Windows boot process happens. Now that we understand the boot process, let's discuss some common issues and how to resolve them. Post failures. If your computer does not pass post, you can check for loose connections or faulty hardware. If there's a missing boot manager, rebuild the BCD using recovery tools or reinstall the OS. Kernel crashes. You can boot into safe mode to disable faulty drivers. And if your boot time is very slow, start by disabling unnecessary startup programs using Task Manager. Understanding the boot stages can help pinpoint where problems occur, making troubleshooting faster and easier. So why is the boot process so important? Why is it important to understand it? Because only then we can know more about a couple of things. Like by knowing what processes occur, you can optimize your startup for speed. You will have the knowledge to diagnose boot issues. Malicious software often targets the boot process. Awareness helps in identifying vulnerabilities. And hence, this knowledge is invaluable, especially for IT professionals, developers, and cybersecurity enthusiasts. In summary, the Windows boot process is a highly coordinated series of events that transitions your system from a powered-off state to an operational environment. From post to the desktop, every stage plays a critical role. I hope now you have a better understanding of this process, and thank you for joining me on this deep dive into Windows booting. Until next time.